wants me to, it has that 1/5 out in front, so in order to do that, well, how would I do that, Cassie?
You could pull out the 1/5 from the 3x plus 2 over 5. So then once you like pulling that and act as if it's not there, you just get 3x plus 2.
You just get 3x plus 2. So you guys should be very comfortable in rewriting this both ways. Does that make sense? That you should realize that this is the same thing as this. Yeah, so this answer is just going to be this 3x plus 2. Okay, the next one, I want to write the fraction as a sum or 2 or more terms. Xavier, what did you do?
So, just split up offset x cubed over 3x squared minus x the fourth over 3x.
Okay. And what are you doing to simplify?
First one, you x squared. The x over 3. And then the second one, x squared. So, 5x squared.
Okay, the most common mistakes, you can only do this if you're dividing by a monomial, in other words, one term. You cannot separate if you're dividing by more than one thing. And then the second thing is once you have it here, don't make the mistake of putting them back together because you wouldn't want to put them back together. Does that make sense? Okay. So now I'm going to ask you, are there any questions on the homework? Yes, ma'am.
Number 10.
Okay, so number 10 is asking what's wrong with this. So if I have this one, I could rewrite as 1 over, that's bad color choice. I could rewrite 1 over A plus 1 over B, because that exponent goes just to what it's with. Does that make sense? But this one, since the whole thing is raised to negative first power, what would I do with the whole thing? Just flip it, say it's a reciprocal. So this would be A plus B over 1. They end up not being the same. You want me to do all the work? I'd love to do all the work. You want to do all the work? Because these two, to add these two, I'd probably multiply, to simplify this one, I'd multiply this by AB. So this would be A times B over B plus A. So that's not the same thing as that at all. Okay? So that was 10, 23. I think 23 is the one I did not, yeah, for some reason oh no, I think you got that. I could not find that last one. All right, so when I go to do this one, when I look from the left to the right is telling me what I should be able to factor out. Okay, the 2x plus 1 to the 3 halves makes sense because that's the lowest exponent between these two. But before I start, I'm going to want to rewrite this. I don't like the way it's written. I don't like having those fractions in front. So I'm going to choose to write it as 2x plus 1 to the 5 halves over 10. Are you good with that? And then I'm going to have minus 2x plus 1 to 3 halves over 6. And I'm going to try and prove it's equal to that, but I'm going to be lazy and not write that every single time. When I go to do this, in order to combine two fractions, because right now I have two fractions, one with a denominator of 10, one with a denominator of 6. In order to combine them, I have to have a common denominator. B, what would my common denominator be? What's the lowest number that both 10 and 6 will go into? I know you're looking at the other side and you're trying to make it 15, but 15 is not it. 30. So when I go, so if I make this 30, what do I have to multiply 10 by to get 30? 3. So I'm going to multiply both of these by 3 and both of these by 5. So when I rewrite that, I'm going to have 3 times the quantity 2x plus 1 minus 5 times that quantity. I'm going to write this all over 30. You're right that I'm eventually going to want to have a denominator of 15, but I'm going to have to work to get that. Okay, when I look at this, now I have one fraction. They're on top of that common denominator. Riley, what am I going to factor out of the numerator?
3 times 2x plus 1 to the 3 halves.
I agree with the...
Oh wait, not 3, just 2x plus 1 to the 3 halves.
2x plus 1 to the 3 halves, because that's the lowest power. What's left when I factor that out, Ben?
Factor it out.
Yes. What do I have to multiply this by to get this?
3.
3. And then this point, 2x plus 1 has an exponent of 5 halves. This one has, I factored out 3 halves. So how do I figure out what exponent? I have to have that 20 here, because I didn't factor the whole thing out, right? How do I figure out what the exponent is going to be on that? Yeah, I'm factoring it.
I don't know.
Let's phone a friend. Done? Yeah, you would take that 5 halves, which is what you have up here, this exponent, you subtract what you're factoring out. You get 2 over 2, which is just going to be 1. So I can write a 1 there or leave it the way it is. So that takes care of the first term. Then I'm going to have minus, and then what do I get when I factor out from the second term? We'll pick on Ben some more.
So, after you factor out the second term,
Yes.
5.
Add 5. Anything else?
No.
No. Why not? You don't sound sure.
Well, you had more than to be 0.
Yeah. Well, yeah. So anything raised to the 0 power is what? 1. So I wouldn't have to write that times 1, right? Okay. Now that I have that, Elisa, what are you gonna do?
Would you distribute the 3?
When I distribute 3, I'm going to have 6x plus 3. So that simplifies to what?
X plus 3.
I'm so confused.
Oh, I don't know. Sorry. 6x minus 2.
Thank you. Now remember, the one I'm trying to get it equal to had a 15 down in the denominator. How do you think they got that 15? And I can't do anything with this, right, because it's raised to that funky power. Can I factor anything out of 6x plus 2? Or 6x minus 2? 2. So I can write this as 2x plus 1 to the 3 halves, factoring out that 2, and then x minus, 3x minus 1, all over 30. Now what can I do? Do you agree that I could rewrite this like this, right? Huh? You can simplify this, and this will be 15. Now when I compare my left side to the right side, this is what should have been equal to the whole time. And we had that blue box, what is over 15. So now that I have that, I can see that I have this. Oh, bad highlighting choice. Look at that. I have this. I have the 15. So what has to go in that box? Hasn't it?
3x minus 1.
Or 3x minus 1. Easy? Yes, ma'am?
I did a little bit differently, but I got this.
As long as you did everything correctly. Yeah, there's different ways to do it.
Okay. Yeah.
Any other questions on the homework? Okay, perfect. Let's finish off those notes. No, we're going to do more. Don't worry. Don't you worry.
Yes.
So this one you have on the note sheet. So when I go to do this, first thing I'm going to do, again, it bothers me when I have that fraction written like that. So I'm going to rewrite it so that I have a clear cut denominator. Does that make sense? So I'm going to write this t plus 1 to the 7/3. I'm going to make that over 7 and put the 3 here. You good? I'm going to do the same thing with the 3/4. Now these first couple ones, when they give you these little blue boxes, they're trying to make it easy for you. I think it makes it hard, but they're trying to make it easy for you. They're trying to tell you what you're factoring out. Does that make sense? So like in this case, if I'm looking at just the left side, I have a fraction that's written over 7, I have a fraction that's written over 4. In order to have a common denominator, I have to find the lowest common denominator. And Caitlin, what would the lowest, oh, that's so bad. What would the lowest common denominator be between 7 and 4? 28. So in order to make the common denominator 28, what am I going to multiply by, Contessa?
You're going to multiply first one by 4 by 4.
So when I do that, I'm gonna make, well, I'm gonna do it my way. So I'm just gonna write 4 times 3. I know that bothers you. And this is all over 28. And I could keep on copying this down, but to save time, I'm not going to do that. Okay, so now when I'm looking at this, I'm going to look to see, once I have it over a common denominator, and if I give you a common denominator, you're not going to want to go backwards and take away that common denominator. Does that make sense? And you'll be amazed at how many of you will try and do that in about 5 minutes. All right. So this one, what can I factor out? What is the lowest thing that I can factor out? Nathan?
3 times t plus 1 plus 1/3.
And that's why I didn't bother multiplying the 4 times the 3 and the 7 times the 3. But if I had 12 and 21, I could still factor out that 3. Does that make sense? I was trying to save you some work. All right, Kate, when I factor out that 3 times t plus 1, what am I left with here? Okay. Oh, I'm saying Kate, it's Sarah. I am so sorry. As the second sibling of the same sex, I'm really, really sorry.
It's okay. You're left with 4 t plus 1. So, just go 1.
With the 1, so I don't have to write it. And then the second one would be? Bailey? Just minus 7. And then this is also over the 28. What's the next thing I'm going to do, John?
You're gonna use the bracket to 4 plus 4 minus
Okay. I'm up there. 4t minus 3. Everyone good with that? He skipped steps. We're okay with that? Now what I was trying to prove it equal to what technically goes into that box. Then he, yeah, the 14 minus 3 will be the answer to that. Now was that bad? That wasn't bad, was it? Okay, let's try another one. Last one on your note sheet is this guy right here. Yes? Am I on the right one?
Yes.
Huh? It looks like a lot, but can I make it look easy? I'm gonna clean, I like to call it clean it up. I'm sure that's not the official math term. But see how this, if I highlight, let's highlight. This is my first term, yes? Everyone agree? This is my second term. And I know they're first term and second term because they're separated by that subtraction sign. Everything in the first term is being multiplied. So what's nice about that is if I'm multiplying everything in the first term, I can change the order that I multiply in, use the commutative property of multiplication. So I can rewrite this as negative 6x to the 6th. See where I got that? I multiplied x to the 5th times x. That's how I got that x to the 6th. And I multiplied negative 3 times 2, and that's how I got that negative 6. Isn't that a lot easier to look at than everything that's above it? So how am I going to rewrite the green one? Oh, it's Joey, but Joey's not here. Alexa. Now all I'm going to do is bring the monomial out front. That's all I can do in that second one. And then what's my denominator going to be, Alex? X to the 10. Now that I have it written over one common, it's over the common denominator, I'm going to try and simplify by factoring stuff out of the numerator. Oh, and what can I factor out of the numerator? Well, when I look at -6 and -5, can I factor anything out of those two?
5x.
I agree with the x to the fourth. But can I factor out a 5 from here?
No.
No, so I can just, the lowest thing that I can, the greatest thing that I can factor out from that -6x to the 6 and 5x to the fourth is x to the fourth. I could factor out a negative sign if I wanted to, that's your personal preference, doesn't matter. If you did not, so I'm not going to. Good? What else can I factor out? What else do they have in common?
Maybe factor out x squared plus 1 to the power of -3.
Which one's lower, -3 or -4?
-4, sorry.
-4. Now when I factor that out, what am I left with? Bella? You done? Bert? You know why? I feel like you're not sure. Huh? Yeah, so I take -3 minus a -4, and that's how I get 1. And this is all over x to the 10. Right, come on. What do I do now? Are we multitasking? Can we multitask?
You could distribute the -5 to x squared plus 1.
Okay, I'm going to cheat when I do that. So this will be -5x squared minus 5. Okay. So what does this whole quantity end up being? -6x.
Negative x. Negative x squared.
I'm not writing off that easy. So, which do we want to deal with the x to the fourth first, or this quantity here first? So, if since it has an exponent of -4, what should I do with that whole quantity? Give it the denominator. So I'm going to have this x squared plus 1 to the fourth in the denominator. And then when I have, what do I do with that? I could leave it like this. No, well, I could leave it like that. That would be wrong. I don't like that. Why don't I like that at all? There? X is 6, and what in the denominator? X is 6. I'm going to put it in brackets. I like my monomials in front. So what I did is I simplified 4 and the 10, and then was left with x to the 6. Because you subtract x from the divide, yeah? Was that terrible? I feel like if I walked away and gave you a quiz on this, it would be a disaster. Do you all agree? So, let's start with, I believe this is, don't look at that work because that's all wrong. I think it's 47. Open your book to 47.
Okay, after this is
Okay,
done.
so you're working on this problem. I'll give you a minute or two.
Okay, so we can combine.
Alright, I'm hoping what most of you did, and you can tell me that, no, if you multiplied 3 times 1/3 right off the bat, get rid of that fraction. And then what I'm left with is this 3x minus 1 is what I'm going to factor out to negative 2/3 power, and I'm left with 2 times 3x plus 1 minus 2x plus 1. And this is all over 3x minus 1 to the 2/3 power. Now that I factor this out, I can bring it down because it has a negative exponent, and only when I factor out can I do that. So now this will be 6x plus 2, and then this will be minus 2x minus 2. So I end up with 4x minus 3.
It's 3x minus 1, not this.
Oh my. 3x minus 1. And then this is minus 1. Oh my, I made a lot of mistakes. 3 minus 1 is 4/3. Good? I just have one thing to say, because it's going to be on the next one that we do. If I had something like 1/2 times, let's say, 3x plus 7, if I had this and I asked you to simplify it, let's put it over something.
I don't either.
If I had that, and I asked you to simplify it, that 1/2 is a huge problem, yes? So, but let's suppose, I'm going to show chunking. Let's suppose I chunk this, and by chunking that means I'm going to say A is equal to 3x plus 7. So if I had this, if I had A to the negative 1/2 power plus 1/2 times A to the 1/2 power all over A to the 3/2 power, a lot of powers. When I go to do this, I'm going to rewrite this at first and think of this as A to the negative 1/2 over 1 plus A to the positive 1/2 over 2. Are you with me? And this is all over that denominator. In order to get rid of that 2, what am I technically going to do? Does anyone know?
Multiply the left half by 2.
So I can do it that way, where I'm multiplying this by 2 over 2, so I'd have 2a to the negative 1/2 plus a to the 1 positive 1/2, and this would all be over 2, and that whole thing would be a over a to 3/2. Again, how do I get rid of that 2? Multiply what by 1/2? I don't know what you want me. What specifically do you want me to multiply by 1/2? I don't want to multiply by 1/2. I'm going to be perfectly honest. I could probably multiply both the numerator and denominator by 2. And if I do that, these 2's will simplify. And then I'll end up with 2a to the negative 1/2 plus a to the positive 1/2 all over 2a to the 3/2. That's probably what I would do. But in order to do that, in order to get rid of that 1/2, since one of them had a fraction, the other one did not, I'm going to have to multiply by. Probably the easiest thing would have been to do at this step here, multiply by 2 over 2, and I would have gotten the same thing. Does that make sense? Yes? Yes. 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 Now what do I, it's this way. There to go. 58. So working on 58. Know that you will not be able to simplify because one of your exponents that you're left with is a fraction, so you're just going to leave that binomial in that parenthesis with the fraction. The person who was... Okay, on this one I'm going to chunk it to make it slightly easier. I don't know if it'll make it easier or not, but we're going to try it. So I'm going to say, let's say I say A is equal to 3x plus 2, and I say B is equal to x minus 6. Now when I go to rewrite it, you're like in control of rewriting it. Does that make sense? As long as you rewrite it correctly, you can rewrite it any way you want. So I'm going to stick to alphabetical order, is what I'm trying to say. So here, when I multiply my 3 and my 1, that would just be 3. Then I'm going to have, I don't need that parenthesis. I don't want that parenthesis. So I'm going to say 3a to the negative 1/2, b to the positive 1/2. Everyone's good with the first term, yes? Then I'm going to do plus, and then I have negative 1/2 and a 3. See that? So I'm going to have a negative 3 halves, yes? And the reason why I'm doing that is then I'm going to make this a, so this is my a to the negative 3 halves, b to the third. And I'm going to write it like that. You good? So now when I look at this, this is understood to be over 1. In order to add them, what would I have to have? Common denominator means I'm going to have to multiply this whole thing by 2, and then that will give me a denominator of 2, yes?
Yes, correct.
So I'm going to have 6a to the negative 1/2, b to the positive 1/2, plus, I don't like to make a minus, I didn't, a to the negative 3 halves, b to the third, and now this whole thing is over my common denominator of 2. Now I'm going to factor out what I can. I have a 6 and I have a 3. What's the lowest common denominator? Let's common factor 3. And then a to the negative 3 halves. And then b to the 1/2. That's what I'm factoring out. Then I'm going to have, here I'm going to have 2a and then b factored out. I'm switching to the minus now. Are you okay with that? I factored out the a. 3 minus 1/2 is 3 minus 1/2, 6, 5 halves. Why should I not think of that? And this is all over 2. Now, you're right. Once I have it this far, my original problem didn't have a's and b's. I'm the one who put those in there. So my a is 3x plus 2. Can I multitask? I'm going to put that in the denominator since I have a negative exponent. Are you good with that?
Then what if the negative go away?
Oh, right. Thank you. That's like twice the common to 6. X minus 6.
It depends.
Oh, grab it too. Yep. 1/2. So when I had this, I multiplied this times this, and that's how I got the 3 halves. Oh, because when I factor on negative 3 halves, this one originally had an exponent of negative 1/2. So to find this new exponent, I took negative 1/2 minus a negative 3 halves, and that became 2 over 2, which is 1. So this exponent is 1.
Anything.
Oh, I'm
Doesn't sound
sorry.
bad. Could be worse.
I'm so sorry. Thank you. I like to explain for no reason else. All right. So now, when I do this, 3x minus 6 to the 1/2, yes? And then this is going to be times 6x plus 4. Minus x minus 6 to the 5 halves, all over 2 times 3x plus 2 to the 3 halves. Cannot do anything with this because it's raised to that fractional power. And what was the other thing I was going to say? Cannot do anything because this is raised to fractional power. If it's anything above 2, I'm not going to ask you to cube a binomial. Does that make sense? That's it.
Can we distribute the negative or
No.
Sorry.
I know.
No.
If I have 3 times x plus 4 to the 1/2, can I make that 3x
just the
So
regular
if you
exponent?
distributed a negative sign, you would technically be distributing that -1, and you can't do that. Does that make sense?
Yeah.
Yes, sir.
Can you distribute if the exponent's not a fraction?
No,
No. Okay.
because this one, my little thinking bubble, okay, I do. This was 3x plus 4 squared, you're trying to make this 3x plus 12 squared, no, because this is x squared plus 8x plus 16.
Think about it.
Don't even
Alright.
think about it, yeah.
Well, I made it look
So what we did over there by
Alright, here's your homework. If you did not understand 53, there's no harm in doing 53 again and not looking at and checking your work, right?
correct.
No. So that's your homework, everyone has that?
It's on Blackboard.
It's on Blackboard and it's on Blackboard. And there's no